morning, my dear students. Today I will start a BSc 6th semester. The yesterday chapter will be continued. That is what is called as bio-inorganic chemistry. The bio-inorganic chemistry. Yesterday we discussed about that is macro elements, micro elements, then macro trace elements, micro trace elements, essential and non-essential trace elements should discuss yesterday. Then we should discuss what is called as the hemoglobin and the myoglobin. The oxygen carriers to the body of the system will be discussed. The structure of hemoglobin and myoglobin, as well as the different the microelements like zinc, copper, arsenic, molybdenum, iron, cobalt, nickel. All these metals. What is the role of these metals in the biological systems? So today we shall discuss what is called as Metallo Enzymes. Today we shall discuss Metallo Enzymes. The Metallo Enzymes means these totally there are the 1500 Metallo Enzymes. Totally there are 1500 Metallo Enzymes. So these enzymes are catalyzed for a biological systems. These enzymes are catalyzed by the biological systems. Their basic structure is built of proteins. Their basic structure is built of proteins. So enzymes which are of interest into inorganic chemistry are those which are composed of a protein structure are called as apoenzyme. So and a small prosthetic group, apoenzyme as well as a small prosthetic group is very small prosthetic group is so then we will be having which may be a simple for a complex metal ion, a group that combines reversibly with an enzyme for a particular reaction and is then released to combine with another enzyme is termed as the coenzyme. A coenzyme will be linked with the coenzyme. It forms what is called as metallo, the enzymes. So these metallo, the prosthetic groups and the coenzymes are also called as cofactors. So that is a prosthetic group or the coenzymes. The coenzymes will be called as, so that is these compounds will be called as cofactors. Coenzymes and cofactors will be called as, so that is the prosthetic group and coenzymes will be called as cofactors. The more here it will be having totally 1500 metallo enzymes. Among those there is 6 what is called as metallo enzymes. The first one will be called as phosphohydrolysis and phosphotransferases. The first one is what is called as phosphohydrolysis and phosphotransferases. All will be contains the metal is magnesium. The metal is a magnesium. Then second one what is called as the cytochromes, peroxidases, the catalysis and peroxidase, pyridoxine contains iron. The second one will be like this is that the cytochromes, peroxidases, the catalysis and pyridoxine contains that is iron. The third one is tyrosine. The third one is tyrosinase, the amino oxidase, the cytochrome oxidase and ascorbate what is called as oxidase and galactose oxidase contains copper. The third one metallo enzyme is this one is tyrosinase amine oxidase, the cytochrome oxidase, ascorbate oxidase and galactose oxidase contains a copper. Then fourth one will be called as, so that is metallo enzymes is nitrogenase contains, the nitrogenase contains both will be called as iron and molybdenum. The nitrogenase oxidation will be contains iron and molybdenum is and the fifth one what is called as arginase. The fifth one that is metallo enzymes is arginase and oxaloacetate. A decarboxylase contains manganese. And the last one is alcohol dehydrogenase, alkaline phosphate and carbonic anhydrase and carboxypeptidases all are containing the zinc. I will repeat it once again. The sixth one metallo enzyme is the alcohol dehydrogenase, the alkaline phosphate and carbonic anhydrase and carboxypeptidase all containing the zinc. So all containing zinc is. So now we shall discuss one by one what is called as these the metallo enzymes. So the different functions of the metallo enzymes will be like this is the first one will be called as carbonic anhydrase, the second one will be called as carboxypeptidase, the third one is peroxidases, the fourth one is catalysis and fifth one is cytochromes P450. The cytochromes P450. So the first one is carboxylase anhydrase, second one is carbonic peptidase, the third one is The third one will be called as the third one will be peroxidases. The fourth one is the cytochromes. The first compound is what is called as a peroxy. The first one is a carbonic. The first one is carbonic anhydrase. The second one will be called as a carbonic peptidase. Then the third one is peroxidases. Third one is peroxidases. Third one is peroxidases. And the fourth one is catalases. The fourth one is catalases. And the fifth one is a cytochrome. The cytochrome P450. The P, the 450 is the P, the 450 is a P, a 450. So here these are the Metallo enzymes. These Metallo enzymes are classified into, that is what is called as carbonic anhydrase. The first one is carbonic anhydrase. Second one is carbonic peptidase. The third one is peroxidases. The fourth one is catalases. And the fifth one is cytochrome P450 is. So cytochromes P450 is. So what is the first one is carbonic anhydrase. The carbonic peptidase. The third one is what is called as peroxidases. The fourth one is catalases. And last one is the cytochromes, the P-450. The P-450. So here, what is carbonic anhydrase? The carbonic anhydrase, the Metallo enzymes, it will be contains mainly magnesium atom. It will be a magnesium, the Metallo enzyme, along with the 3 nitrogen atoms. Then the second one is the carbonic peptidase. The carbonic peptidase is also the Metallo enzyme. It also contains the main metal is a magnesium is there. So these two are present in the plants. They are present in plants. That is, it will undergo photosynthesis the plants because of chlorophyll. Because of a chlorophyll. The third one is the peroxidases. The peroxidases is also Metallo enzyme. It will be having the, it will be contains the iron metal. It will be contains the iron metal. Then fourth one is the catalases. It also contains the metal. The iron is there. And last one cytochrome, the P450 is also contains what is called as the iron metal. The iron metal is there. Under that, now we shall discuss one by one. What is called as the carbonic anhydrase, the carbonic peptidase, the peroxidases, catalases, and last one is a cytochrome, the P450. The first one is what is called as the carbonic anhydrase. The first we shall discuss, that is the carbonic anhydrase. The carbonic anhydrase. So usually the carbonic anhydrase will be having a structure will be like this. At the center there will be a zinc metal, and it will be having the water and the molecule linkages will be like this. This is the first nitrogen atom, and this is second nitrogen atom, and this is a third nitrogen atom. So here the chain will be continuous. So this is called as the zinc. This is called as carbonic anhydrase. This is structure of a carbonic, the anhydrases. So it will be linked with the water molecule. Then the 3 nitrogen atoms will be called as Yapo enzyme. Here there is a portion will be called as the Yapo enzyme. This is called as a portion, the Yapo enzyme. This is the general structural formula of a carbonic anhydrase. The carbonic, the anhydrase. So here the carbonic anhydrase is a zinc enzyme. that catalyzes the hydration of carbon dioxide and the dehydration of carbonic acid. So it will be undergoes a dehydration of that is carbonic acid. The enzymes can hydrate 10 to the power of 6 molecules. It can enzymes the 10 to the power of 6 molecules to carbon dioxide. So it will be converted into, that is a carbonic acid will be converted to carbon dioxide. So that is at 37 degrees centigrade. At 37 degrees centigrade per second it will be converted, that is carbonic acid into a carbon dioxide. Okay. About the 10 to the power of 7 times the faster than the uncatalyzed rate of hydration of carbon dioxide. Carbonic anhydrase with a molar mass about 30,000. There will be 30,000 occurs in animals and the plants. The carbonic anhydrase will be present in animals and the plants nearly at 30,000 molecules. And in the human system, the carbonic acid present in the human system, that will be converted to carbon dioxide. That is at 37 degrees centigrade per second it will be converted. That is 10 to the power of 6 times. So then these histidine groups. Then the next is the structure of what is called as carbonic acid. The structure of the carbonic acid. So here this is what is called as a zinc. H, O, and this is the H, and this is the H. It will be a carbon dioxide. Carbon dioxide. This is N minus carbon dioxide. So it will be changes its structure. It will be like this. Again, it will be changes into the another form. So that's a zinc, O, a zinc with the O. C, a double bond O. This is a O. H. Again, this compound will be changes to Zn plus 1. This is O, H, and this is a H, and this is N. This is N, and this is N. This is there is a removal of H plus 1 and water will be liberated, and then H plus H2O. So further it will be changes into this compound, that is HCO3 the minus 1, and again reversible reaction forms the same carbonic acid, the zinc, O, and this is C double bond O, and this is the H, O, and this is the H. So this is called as the probable mechanism of reversible hydration of the carbon dioxide. So that is, here the first step is this zinc ion, that is a Metallo enzyme. So it will be undergoes, that is in the forward reaction, the hydrogen ion will be liberated and the water molecule will be liberated to form this structure is there, and this is a reversible reaction, that is minus H plus and the minus of a water molecule. Once again it will regains the original structure is there. Then, in the second step, there is a removal of a carbonic acid. There is a removal of a carbonic acid to form ZnO, single bond OH, and C double bond OCOH. Then, the third step is it is a reversible reaction to form zinc with the 3 nitrogen atoms. This is C double bond O, single bond OH, single bond C, OH, this one is and then finally it forms this compound to form a product. This is called as a probable mechanism of a carbonic anhydrase. The anhydrase. Okay. So here it will actually depends the Lewis acid acidity, the zinc ion in carbonic anhydrase polarizes, that is coordinated the water molecule to the point of loss of hydrogen ions to form a coordinated hydroxyl group. Like all truly catalytic reactions, catalytic reversible hydration of carbon dioxide is a closed loop. The clockwise cycle. So this is a clockwise cycle. The clockwise cyclic of hydration of carbon dioxide to what is called as a carbonic acid. Carbon dioxide to a carbonic acid, and the anti-clockwise cycle shows that the carbon dioxide from, that is this is anti-clockwise is bicarbonic acid to a carbon dioxide. So the cycle may proceed either by depending upon the concentrations of the reactants in the biological systems. So depends upon the biological systems, we have to come across what is called as this is a carbonic acid anhydrase. The anhydrases. Then the second one what is called as a carbonic peptidase. The second one is a carbonic peptidase. So the carbonic peptidase is also a magnesium. The enzyme is there. The magnesium, a Metallo enzyme. The magnesium, the Metallo enzyme. So second one is a carboxy peptidase. The second one is a carbonic peptidase. So what is carbonic peptidase? A carbonic peptidase is also a Metallo enzyme. This Metallo enzyme is also contains a zinc metal. It also contains a zinc metal. So this Metallo enzyme will be having a CH, or this structure will be like this is C double bond O, the NH, single bond CH, the R dash, and this is a C double bond O, and this is NH, and this is CH R dash, and then finally COOH, the COOH. So it will be converted into, that is water. So that is a carboxy peptidase. It will be undergoes what is called as a carboxy peptidase. The reaction, the carboxy peptidase to get that is CH single bond R, the C double bond O, and this is NH, this is CH, that is R dash, and then COOH plus what is called as a product, the NH2, that is CH R dash, and then the C double bond COOH, the CO, the OHs. So here actually what happens, the C double bond O, the NH. So this is totally what is called as carboxy peptidase. This is a metallo enzyme. With that it will be contains a magnesium atom is there. Here it will be undergoes this molecule will be undergoes what is called as a carboxy peptidase. The carboxy peptidase means when you consume a food, what do you say? This carboxy peptidase it will be having when you consume a food is there, so it will be converted into that is a digestive system that it will be undergoes what is called as carboxy peptidase. Here the bond will be breaks between the C double bond O and NH to form that is what is called as amino acid. This is known as the amino acid. So amino acid means it depends upon the value of R, either hydrogen atom or the methyl group or the ethyl group, whatever it may be, sir. Either it may be acidic amino acid or the basic amino acid or neutral amino acid, and this forms this intermediate compounds. Okay. Then the second structure of this what is called as the carboxy peptidase. The carboxy peptidase. So this structure will be like this is the carboxy peptidase, that is a zinc ion will be having O and this is H and this is the H. So it will be having a nitrogen atom. This is N and this is the H. CH2, this is one group. Then from this there will be an oxygen atom and this is a C double bond O CH2. CH2, this is another A group. Then we will be having third one is that is nitrogen atom. N, a single bond H. This is double bond, this is double bond. The here also same, there will be double bond, and here there will be a double bond, and then this is CH2. This one is. This is totally. This portion will be called as FO enzyme. This portion will be called as FO enzyme. The structure of the zinc enzyme carboxy peptidase. So this is the structure of. This is a structure of zinc FO enzyme carbonic peptidase. Carbonic peptidase. So, what is a carbonic peptidase? So, this is also a zinc enzyme. So,